Hello everyone, our lesson today is solving linear equations. And before we do that, we need to know what are linear equations and how do they look like. Linear equations are just like any equations. They have a left-hand side, a right-hand side, and they are separated by an equal sign. The variable in it needs to be raised to the power 1 for it to be called linear. So let's look at some examples of linear equations. 2x plus 10 equals 12 is an example of a linear equation. It has a left-hand side, a right-hand side, and an equal sign. Notice the variable, which is x, is raised to the power 1. That's what makes it linear. In solving a linear equations, we need to solve for x. What that means is we need to find the value of x that will make this equation correct, in which the left-hand side and the right-hand side will be equal to one another. How do we solve linear equations like that? So let's try. We have 2x plus 10 equals to 12. What is the strategy of solving linear equations? The strategy is called using inverse operations to isolate your variable x. What does that mean? Let's look at the left-hand side. We have two numbers next to the x. One of them is 10, and it's added to the x, and the other one is 2, and it's multiplied by x. So we need to get rid of the 10 and the 2, but which one should we get rid of first? Look at the operation between 10 and x, it's addition. And addition is considered a weaker operation. Multiplication and division are stronger than addition and subtraction. So when we need to get rid of this number 10, we'll do that first before getting rid of the 2, because the 2 and the x are multiplied, and multiplication is stronger. Whenever we are adding or subtracting or doing any operation to the left-hand side, we need to do it also to the right-hand side to keep the balance of the equation. So we need to get rid of the 10 first because it's added, and addition is a weaker operation. So we're going to subtract 10 from both sides. And why did we decide to subtract 10? Because this way plus 10 and negative 10 will cancel each other. Again, we're using inverse operations. Since the 10 is added to the x, we decided to subtract 10 from both sides. And when we do that, we are left with 2x on this side, and the 10 and the negative 10 will cancel out, and you have 12 minus 10, which is 2. Now our equation is simpler. We only have the 2 multiplied by the x, and since they are multiplied, to get rid of it, we can do the inverse operation, and we're going to divide both sides by 2. This way 2 and 2 will cancel out, and we will end up with x equals 1. Well, let's check if our solution is correct or not. Our original equation looked like this: 2x plus 10 equals 12. Let's take the one that we got for x and plug it in and check. So 2 times 1 plus 10. Does that give me 12? Well, 2 times 1 is 2, plus 10 is 12. So our answer must be correct. Let's take another example. 5x minus 3 equals to 17. Again, this is a linear equation with two sides, a left-hand side and a right-hand side. Notice that the x here is raised to the power 1, which makes it a linear equation. Now we have two numbers next to the x, 3 and 5. Notice that the operation between x and 3 is subtraction, and the operation between the 5 and the x is multiplication. So we need to use inverse operations to get rid of the 3 and the 5. And again, since subtraction is weaker than multiplication, we're going to get rid of the 3 first by adding 3 to both sides. Remember, we always do the inverse operation. Now we end up with 5x, negative 3 plus 3 will cancel out, equals 17 plus 3 gives you 20. Now we only have 5 next to the x, and it happens to be multiplied. So to get rid of it, we're going to need to do the inverse operation, which is dividing both sides by 5. So we end up with x, because 5 divided by 5 is 1, equals 4. Now let's check our answer. Our original equation was 5x minus 3 equals to 17. Let's take the 4 that we got, plug it in place of the x, and check if both sides are equal. Well, 5 times 4 is 20, minus 3, that does equal to 17. So our answer was correct. And it's always a good idea to check your answers. Let's do another example. We have x over 4 minus 6 equals to 2. Again, this is a linear equation, and we have 6 and 4 are on the same side as the x. The 6 happens to be subtracted, while the 4 happens to be divided. Subtraction is weaker than division, so we're going to get rid of the 6 first by doing the inverse operation. So we're going to add 6 to both sides. Remember, you have to always do the same to both sides to keep the balance of the equation. So now we have x over 4, 6 and negative 6 will cancel out, and then you have here 6 plus 2, which is 8. Now we only have the 4 in the same side as x, and the operation between x and 4 is division. So to get rid of the 4, we will multiply both sides by 4. So we're going to multiply this side by 4, and we're going to multiply this side by 4. This way the 4 and the 4 will cancel out, and we end up with x equals 32. Well, let's check our answer. Our original equation was x over 4 minus 6 equals 2. Let's take our answer, which is 32, plug it in and check. So 32 in place of x divided by 4 minus 6. What's 32 divided by 4? That's 8. Minus 6 does equal to 2. So our answer was right. Now let's take another example. We have x divided by 3 plus 1 equals to negative 5. Again, we have x on the left-hand side of the equation, and we have a 1 and a 3. The 1 happens to be added to the x, and the 3 happens to be divided by x. So, which one do we need to get rid of first? We're going to need to get rid of the 1 since it's added, and addition is weaker than division. So we're going to do the inverse operation. In this case, we're going to subtract 1 from both sides. So if we do that, we end up on this side with x over 3, and 1 minus 1 will cancel out, equals to negative 5 plus negative 1, that's negative 6. Now we have x and 3 on the same side, and the operation between them is division. And to get rid of the 3, we're going to multiply both sides by 3. When we do that, the 3 and the 3 will cancel out. You end up with x on this side equals to negative 18. Now let's check our answer. Our original equation was x over 3 plus 1 equals to negative 5. So let's plug our solution, which is negative 18, in place of the x, divided by 3 plus 1. What's negative 8 plus 3? Well, that's negative 6. Plus 1 does give us negative 5. So our answer must be correct. Let's do another more complex equation. We have 2x plus 1 equals 10 minus x. This is also a linear equation that has two sides. But notice that the x appears on both sides of the equation. So what are we going to do first? Well, you can get rid of the 1 if you want to, and then move it over there, or subtract 1 from both sides. I advise you in this case to move the x's next to each other. So let's get rid of this x on this side. How would we be able to get rid of this x on that side? Well, If we add x to this side, we get negative x plus x, which is 0. But remember, we have to do it to that side too. If we add x to both sides, we have 2x plus x on this side, that's 3x, plus 1 equals to 10, since negative x and x cancels out. Now this looks familiar. We have 1 and 3 on the same side. We'll first get rid of the 1. Do you remember how to do that? Yes, we need to subtract 1 from both sides. And when we do that, we end up with 3x equals, remember those will cancel out, the 1 and the negative 1, and we have 10 minus 1, which is 9. Now we have 3 to get rid of, and since it's multiplied, we're going to divide both sides by 3, and this way our solution becomes x equals 3. Well, let's check our answer. Our original equation looked like that. 2x plus 1 equals 10 minus x. Let's plug 3 on both sides and see if both sides are equal to each other or not. So 2 times 3 plus 1, remember we're plugging 3 in place of every x. And let's put a question mark. Are those two sides equal? Well, 2 times 3 is 6, plus 1, and 10 minus 3 is 7, and this is 7 equals to 7. So our solution is correct. Let's try to do another example. If we have 5x minus 7 equals 3x plus 1. Again, we have x showing up on both sides of the equation. What I would do is I try to put the x's next to each other. By subtracting 3x from both sides, and remember you have to always do the same operation to both sides, same quantity, same operation. When we do that, notice that the 3x and the negative 3x are going to cancel, and this side will only have 1. And on this side we have 5x minus 3x, well that's 2x, and the 7 comes down. Now we have two numbers next to the x. The 7 happens to be subtracted, and the 2 happens to be multiplied. Which one should we get rid of first? If you said 7, you're correct. And how would we do that? We need to add 7 to both sides. And now we have 2x, 7 and negative 7 are going to cancel out, and we have 8 on this side. Now we have the 2 multiplied by x, so we're going to do the inverse operation by dividing by 2. And we get x equals to 4 as our solution. Now let's check. Our original equation was 5x minus 7 equals 3x plus 1. Let's plug 4 in place of the x and put a question mark because we're still checking if both sides are equal or not. So 20 minus 7, is that equal to 12 plus 1? And the answer is 13, or both sides, which means our solution x equals 4 is correct. This concludes our lesson. I hope that you will go to your textbook and do more examples to master this. Remember that whatever you do to the left-hand side, you have to do to the right-hand side. And you're always looking to isolate your variable using inverse operations. See you next time.